Hello everybody, this is Peter Kolozny, IP expert security instructor. In today's vLecture, I'd like to talk about a router IP traffic export, or sometimes called IP traffic export, or simply RITE, right? This feature is intended to give you the ability to copy the traffic from the network to a certain location. The main advantage of this application of this feature is going to be obviously the analysis of the traffic that is traversing our router and possibly inspection, like with an IDS solution. There are also some other applications, but these two are the most important ones, the most commonly used ones. Now, before I show you the configuration of router IP traffic export, I would like to tell you a little bit about the advantages of this method and also about the limitations of this technology. So the first thing you should know is that at a high level, this technology works the same as span or rspan, meaning that it allows you to copy the traffic from one location. Specifically here with this feature, this is going to be an interface or just the traffic that is flowing through a given port to a different location. Again, an IDS solution or maybe a Wireshark enabled PC. What's going to be the benefit of using a write, for example, versus span or rspan, which is something that we commonly use in switched environments when we want to copy the traffic from one place to another? Well, the main advantage of router IP traffic export is that it allows you to copy the traffic that is traversing a non-Ethernet port. So it doesn't have to be something that we plug into a switch. It can be a serial interface that you configured with, let's say, frame relay or PPP encapsulation. You can copy the traffic that is traversing such as interface to a different point. Now, in terms of limitations, maybe let's take a look at this in the documentation. I also want to show you how to find a document that describes how to configure this technology. So we will go to the main documentation page, and then from here, and this is located under iOS. This is a router feature. So iOS and XOS software, iOS 15M and T, let's choose 15.2, all documents. And then under configuration guides, you have to go under security, services, and VPN, and open up the library, configuration guide library for user services. And there is a document here under user security configuration guide that explains what this feature does and how to configure it, which is going to be this section of this config guide, IP traffic export. So as I said, this is sometimes called router IP traffic export or simply IP traffic export. So as in terms of limitations of this feature, because this is another thing I want to discuss before we take a look at the configuration. So we've got some restrictions, and the first one is that the outgoing interface for exported traffic must be an Ethernet port. So this basically means that the traffic, the copy of the traffic must be sent out of an Ethernet port. Versus what you monitor, which is what you copy, it can be any interface. It can be a serial port, it can be an Ethernet port, it can be something else. And the second limitation is that the device that where you will be sending a copy of the traffic must be directly connected to one of the router's interfaces. And this must be, once again, an Ethernet port. And the reason is that the copy of the traffic that we send is going to be layered to encapsulate it with a destination of a given station's MAC address. So you'll have to know the MAC address of the device where you will be sending the packets to. Okay, let's now take a look at our topology for this example, for the example I will show you today. Maybe let me quickly take a look at the device configuration. We have three routers here, 2, 5, and 7. Router 2 is going to be what I will use to configure the feature. Let's say show IP interface brief. Okay, so Giga1, this is where I will be sending my traffic to, the copy of the traffic, obviously, not the real data. We've got Giga0 and a serial interface connected to a frame relay cloud. So let me go ahead and put it in the middle here. So Giga1 is what I'm going to use as an analysis station. This is going to be simply an intrusion prevention system, one of the 4200 series devices from Cisco. And I'm going to put it as an IDS. So it is kind of like similar to configuring spam on the switches when you want to use promiscuous deployment mode on the sensor. So Giga1 is directly connected with IDS. They are in the same layer 2 network. We will have to figure out what is the MAC address of this appliance. I'm going to show you how to do that. We have another interface, Giga0, which is where this is 8.9.2.0/24, what I've got here. And we've got a serial interface that is connected to a frame relay cloud with another device. I believe that this is router 5. Let's quickly check this. Show IP interface. As you can see, I've got some other configuration on the devices. It says that we are receiving rookie messages, but this is obviously not going to interfere with the config I want to show you. So this is 8.9.50/24, what's configured in the cloud. And this guy uses that 5. And we've got router 7 over here. So 7 and 5, those devices I will be using to test this configuration, to generate the traffic and to receive the traffic. This is that 7 over here. And again, the goal is going to be to, we will focus on one of the router 2's interfaces. This is going to be that serial port. This is that interface where I will enable the feature. So our router IP traffic export config will eventually go to the serial port. Now, question is, how do we configure this feature? So, in general, the configuration is pretty straightforward. It's all about creating a so-called profile, or just IP traffic export profile, and applying the profile to the interface which you want to monitor, which is again one that the traffic will be flowing through. Okay, so the syntax is IP traffic export profile, then you give it a name. I'm going to call it RT1. And now a couple of options here. First thing you should know is that when you apply the profile, it is by default only going to look at traffic incoming to the interface. So the bidirectional option is something you can use to change it. Instead of copying only traffic that is going to that port, so to the router, you can also copy the traffic that is leaving the device, leaving the interface. Incoming command allows you to specify what traffic you want to copy. So not necessarily all IP packets, but maybe just ICMP, maybe Telnet. So this can be done with an access list. You can use the sample option to tell it how many packets you want to copy, or specifically every what packet you want to copy, how many packets you want to copy. Then the interface command, we will use it to specify what is that outgoing interface, which is, in case of write, interface connected to our monitoring station. In our example, this is going to be IDS. MAC address is how you specify the address of that analysis station, which is IDS. And finally, the outgoing command is to restrict the traffic that you will copy, restrict the traffic leaving the interface that you will copy to your analysis station. Okay, Okay, so initially we will start with a really basic configuration. The bare minimum config is going to be to specify MAC address of the device of the analysis station. And in our case, this is IDS. And we see that this IDS is reachable, is connected to Giga1. Once again, IDS. I'm going to use specifically the management interface of the IDS. So management interface and Giga1, they are in the same layer 2 network. The question is, what is the MAC address of this management interface of my IDS? And there is actually a command you can use to take a look at this, to check this out. Show statistics host. So this is what tells me about the MAC address of my management interface. So this is management 0/0. Okay, so let's go ahead and configure this in the profile. So go back to router 2. Interface is Giga1. And then MAC address of the analysis station, or just the appliance that we want to send the traffic to in this case, is this. We'll take a look at the syntax. It uses the dotted notation, not colons. So we will have to slightly modify the format of the address here. So it takes the value like that. And the second step is going to be simply apply this profile to the interface that we want to monitor. So in our case, the profile goes to the serial. This is where I'm going to apply my profile. So go to the interface and say IP traffic, export, apply, and the name of the profile, like that. It says activated the feature on this interface. You can say show IP traffic, export. We have just one profile. As of right now, that is applied. It says that the interface that we will monitor is the serial port. Remember that by default, we will be only looking at incoming packets. So it says bidirectional mode is off, which means that the only packets we will monitor here is something that is received on the serial. This is incoming traffic. So traffic from 5, this is what we will send to IDS for analysis, but not traffic that is leaving that serial interface towards the cloud. So traffic from 7, this is deemed as outgoing traffic because this is from the device outbound, specifically from the interface outbound. This is something that we will by default not copy. Now it says that the sampling rate, which is once again how many packets you want to copy, is basically every single packet. No access list was configured. This is the address of our IDS, and finally it says that our configuration, the profile is applied, the feature is activated. So on IPS, I'm going to show you, the way I'm going to show you that we are actually delivering the packets is simply with the packet display command for this management interface, and I will be looking only for IP packets. So it is going to show us some traffic that is flowing for the serial in the inbound direction, because I've got some applications configured, some protocols enabled in this network. So it shows me OSPF packets, it shows me some UDP 4500. This is going to be a VPN tunnel, probably the Keep Alive package. But what I want to focus here is that we will basically ping from 7 to 5. So this is going to be leaving the serial interface, and when 5 replies back, we should see this copied over to the IDS. So from 7 to 5, this is how I want to ping. 8, 9, 50, 5. If we take a look at IPS, we see that it copied 5 echo replies. So this is once again traffic from 5 to 7. So just the replies, but it didn't copy the requests, because requests are outgoing, are leaving the interface. Remember that by default I mentioned we only copy the incoming packets. Okay, maybe let's enable it once again. This time specifically look for the TCP packets. Make this whole output a little bit more clear. And we will first send a couple of echo packets like what we did previously. So nothing was copied. Actually, we wouldn't be even able to see this because I said I want to look at TCP packets. So maybe let's just send TCP packets. Let's telnet to 5. And we see that the only TCP traffic that we now see that was copied is traffic, again, from 5 to 7. So just the replies. We don't see the initial SYN. We only see a SYNAC, which is a reply, and then the actual data from 5 to 7. So how about if you want to copy all packets, I mean in both directions? You have to modify your profile configuration and configure it with the bidirectional option. So say bidirectional here, and let's see if it is going to reflect this change automatically. So another packet display, which is basically TCP dump, and then we will, maybe let's close this session. Let's clear this output and telnet once again. So it still only shows me traffic that is received, again, once again, incoming to the interface. We have to, let's enable packet display. Let's disconnect. We have to reapply the profile. So anytime you make changes to the profile, you have to reapply this. You have to reapply it. No IP traffic export, RT1. Apply RT1 and then put it back in. Let's double check, show IP traffic export profile. It says that now the change we see is that we will, the bidirectional mode is enabled, which means that we will not only copy traffic that is incoming to the interface, but also packets leaving the port. And it shows me an additional section here in this output. This is for outbound traffic, outbound packets. Again, the sampling mode is set to every packet. So one more telnet. And now we should see the entire conversation, which is a initial SYN from 7. Then we've got reply SYNAC. And finally, final ACK. This is TCP freeway handshake, so we know that now we receive the bidirectional flow. Okay, so maybe two other things I will show in this demonstration. Let's deactivate the profile. Two more things I want to show you is how to use an access list, which is how we restrict the traffic that we will send to the analysis station, and how to decrease the number of packets that we will copy. So we will still use the same profile. It's just going to be, there is going to be basically some other commands I will have to put into that profile to show you that. Let's configure an access list that is gonna match just ICMP packets. Access list 1, 2, 3 permit ICMP any. So the access list is only looking for ICMP packets. We will go back to the profile. Let's say that I'm gonna leave the bidirectional mode enabled. So access list is looking for ICMP packets. No, maybe actually let's change. Let's disable the bidirectional mode. So again, we are only looking at the incoming packets, And now I'm gonna say that I don't wanna copy all incoming traffic to the interface. I only wanna copy traffic that matches my access list, and not all packets that match, but let's say every 5 packets. So this is going to be incoming sample 1 in every 5 packets. Do show round section profile. So let's take a look at those changes. Once again, it doesn't show me anything right now. I have to apply this profile. I have to activate it. And once again, show IP traffic export. So since I have disabled the bidirectional mode, we only see the input traffic section. This is for incoming packets. But now we see that it is going to be copying 1 every 5 packets, and based on the access list. So any packet that is a match for the access list, 1 in every 5 of such packets, we will copy and send for the analysis. So what does that mean? Let's take a look at packet display expression IP. So I want to take a look at all IP packets, and we will telnet to 5. Okay, I don't see anything here. It didn't copy the TCP packets. It doesn't copy the UDP packets. Nothing was sent for analysis. And the reason is that this traffic doesn't match my access list, right? But when I ping, let's say 20 times, so remember that we are sampling 1 in 5 packets. This means that we should see 20 divided by 5 is 4 echo replies, which is exactly what it shows me in this output here. So once again, the access list is something you can use to tell exactly what traffic you want to monitor, you want to copy. And if you want to go one step further, you want to limit the amount of traffic you will copy, you can use that sample command the sample 1 in every, that allows you to copy just subset of the packets, not all of them. Right, so as usually, if you guys want to learn more, you want to take a look at some other free resources from IP Expert, you can visit our YouTube channel or our blog. If you're looking if you want to discover about the changes, promotions, and our product portfolio, you can always find us on our website, on Facebook and Twitter. Thanks for joining.